Hey there, and welcome back to Educately's chemistry course. Today, we will be continuing our journey into the realm of stoichiometry. To start, I'm introducing you to the simple yet effective guidelines that you can follow when solving complex chemical equations. First, collect the relevant data, which means counting the number of atoms on the reactant side and product side. Next, balance the elements with the greatest number of atoms in any of the reactants or products other than oxygen and hydrogen. Next, balance all the other elements except for oxygen and hydrogen. Balance oxygen or hydrogen, whichever one is present in the combined state. Leave until the last whichever one is present in the uncombined state. The coefficient of the equation must be a whole number. It is required that any fraction should be cleared. In an advanced balancing chemical equations problem, many chemical reactions involve more than a total of 3 elements. Balancing these more complex equations involves the same principles as used in the previous video. This is the reaction between iron sulfate and potassium hydroxide. First, we must count the number of elements on each side, product and reactant. Notice that the number of atoms on the reactant side, respective of its element, are not the same with the number of atoms on the product side. From the guidelines, we will balance the element iron and potassium as they contain the greatest number of electrons beside oxygen and hydrogen. Since in the reactant side there are 2 atoms of iron, the coefficient of iron hydroxide in the product side is also 2. The same goes for potassium in the reactant side with a coefficient of 2 since the product side contains 2 atoms of potassium. From the reactant side, we know that there are 3 atoms of sulfur present in iron sulfate, and on the product side only 1 atom of sulfur present in potassium sulfate. We can balance the number of sulfur atoms by putting the coefficient 3 beside potassium sulfate, making the number of sulfur in the product side 3. Looking at the number of atoms in hydrogen, both on the reactant side and product side, you can see the magnitude differs by a factor of 3, and since hydrogen is part of potassium hydroxide compounds, we replace the coefficient of potassium hydroxide to 6 to balance the elements. Recalculating the number of atoms present in each of the elements, again with the coefficient of 6 now in place, you can see that both the number of atoms in the reactant side and product side are equal. Therefore, we conclude that the coefficient for iron sulfate is 1, as there is no need to add more atoms in the reaction, and thus the reaction between iron sulfate and potassium hydroxide is balanced. That brings us to the end of the video. Thanks for watching, and we'll see you in the next one.